Okay, we are looking at sets, and today we're going to look at the types of sets. If this is the first time joining me, please go back to the last video, because in the last video I explained what sets are, and today we're going to be looking at the types of sets. There are actually many types of sets, but just few are necessary. But we'll go through the ones we can. And the first one, which is, and look at the symbol for that. We use this. Either you write 0 and cancel it, like write a 0 and cancel it, or you use a set bracket, a curly bracket, but nothing will be inside the curly bracket. So that's another way we use to represent set. Either you write 0 and cancel it, or you just write an empty set, like a set that has nothing inside. So when you see that, you know we're talking about an empty set. So now this type of set is just saying this is a set that has nothing inside it. A set that has nothing inside it, that's an empty set. You can write a set, or if you see any set that has no elements, it's empty. Now the second one is what we call a singleton. A singleton, or you say a single set. I know most of us understand what singleness means. When you are not married, when you don't have anybody. So a single set is a set that is single. That's a set that is alone. So when you have a set that has just one element, that set is said to be a single set. Like in this first one now, if I'm asked to get the cardinality of the set, remember what we said, what I explained cardinality as. Cardinality is the number of elements in that set. So the cardinality of the set here is 0. In null sets, the cardinality of the set is 0, meaning it has no elements. Why a single set? If I have a set A, which is having elements 1, the cardinality of A, which we write this way, n of A, is going to be 1 because it has one element. If the element is 4, it's still 1 because it has one element. I hope we get that. So when we say cardinality means number of elements in that set. So a single set is a set that has only one element. Then the next one, we have a subset. Very important. A subset. And the symbol comes in two ways. More like a curved C, or this other one that has equality under it. So it's either you are seeing just this or you are seeing this. Whenever you see those symbols, it means subsets. We actually have two kinds of subsets. A proper subset, which is this one. This is a proper subset. Why this one is improper? Now quickly, I'm going to differentiate these two. Now a subset first is like a set, another set that has all the elements of a set. Like if I say that A is a subset of another set B, it means that the elements of A are found in B. Like let me take an instance. If A is 1, 2 and B is 1, 2, 3, the elements of A are gotten from B. So I can say that A is a subset of B because the elements of A are gotten from B. So we'll write it this way: A is a subset of B. But if I have another set C that is 1, 2, 3, whether like this or they write it like this, sometimes it will come this other way. Now notice the same element that is here are the same elements that are here, just that they are scattered. Now in sets, the way you write it does not matter. If you don't want to write 1, 2 and you write 2, 1, it's still the same thing as 1, 2. The order does not matter, the arrangement does not matter. What we know is that as long as they are the same elements, it's the same thing. And you cannot write a set like this, 2, 2, 1, 1, and say that this set has 4 elements. It's a lie. It has only 2 elements. The 2 were repeated, so you can clean 1, 2 and clean 1, 1. It has just 2 elements. You don't repeat elements in a set. The same thing, the arrangement does not matter. So if you look at C is having everything B has. So C is said to be an improper subset of B. It's improper that you should have everything I have. Even if we are twins, we cannot be exactly the same persons. So C is improper subset of B because everything B has, it has it. Why A is just a proper subset of C because the elements of A are gotten from B. A is a proper subset of B because the elements of A can be gotten from what? B. So that's what we mean by subsets. We call a universal set. Universe. A universal set. Now we actually represent this with something that looks like a U or mu, but a U. Now a universal set is called a mother set. It's a set from which other sets are formed from. I will tell my students in class, it's a mommy set. Yes, the universal set is a mother set, a set from which other sets can be formed from. So the children of universal sets, we now call them subsets. Now those sets that are gotten from universal sets, we can now call them the subsets of the universal set. Why subset is gotten from universal sets? Like the mother set is what we call the universal set. I don't know if that's clear. So if my universal set is a set of English alphabets, if my universal set is a set of English alphabets, I'm using set builders now. I don't want to start listing English alphabets. So a set A can just be vowels. A set A can just be vowels. It's a subset of this universal set because all vowels are still alphabets. If I have another set which is just H, I, J, it is still a subset of the universal set because H, I, and J can be gotten from our universal set, which is the English alphabet. So that's what we mean by universal set. If you have any set that different other sets can be gotten from it, we call it a universal set. Then the next type of sets. Now the next type of set we have is called a power set, Ike set. If you're able to understand. So the next type of set we have is a power set. A power set. Now a power set is a set that is having different kinds of subsets that can be in a set. In other words, power set is a collection, is a set of, a power set is a collection of all possible subsets of a set. A collection of all the subsets of a set. That's a power set. Example, if I have A, and A is 1, 2. Power set of A is now asking, what are the possible subsets of A? If I start this now, it is possible that the subset of A will be 1. Another subset of A can be a set containing 2. Another subset of A can be a set containing 1 and 2. Another subset of A is an empty set, a set that has nothing. It's also a subset of A. So now, the cardinality of the power set of A is 4. Please note this, that every set has the subsets, the whole set, and the empty set. Let me rephrase that. A whole set and empty set is a subset of every set. If you are to write the subset of any set, just know this, that an empty set and the set itself is a subset of that set. Like what happened here? The empty set is a subset of A, and the whole set, which is 1, 2, is also a subset of A. So the set that is collecting all those subsets together is now what we call a power set. And there's a formula to know how many elements your power set will have. The formula is 2 raised to power n, where n is the cardinality of the set. What do I mean? Like this case now, to know how many elements, how many subsets A can have, all I have to check is what is the cardinality of A. Cardinality of A, 2 elements, that's 2. So I'll now do 2 raised to power 2. 2 raised to power 2 is 4, meaning that A power set of A is going to be 4 elements. That's power set of A will have 4 elements, and that's to say that A has 4 subsets. So if I have another set B, which is A, B, C, power set of A power set of B now is going to be 2 raised to power 3 because B has 3 elements. So the subset are going to look like A, B, set C. We have exhausted a single set. We will now go to double. That's A, B, A, C. Remember, you don't repeat elements. A, B is same thing as B, A. So don't write B, A again. So I'm done with A, C. Next thing is going to be B, C. And I'm done with double sets. I will now go to 3 sets. A, B, C. How many do we have? 1, 2, 3, 4, 5, 6, 7. And remember we said that the power set of B is going to be 2 raised to power the elements of B. And B has 3 elements, meaning 2 raised to power 3, which is 8. So B is meant to have 8 subsets, but we have 7 here. The last one is the empty set. That's what is going to complete it. So a whole set and an empty set is a subset of every set. Let's take it down. A whole set and an empty set is a subset of every set. So that's how to get power set.
So thank you for staying with me. You can check out my YouTube channel, engage my posts, and the Lord bless you.